So good evening, Namaste. A very warm welcome to all participants joining us for session 2 of TTD 2026, titled AI Native 6G. I am Chandrakanta Rathod, the session coordinator for today's session, and it is my pleasure to welcome you all. Before we begin, I would like to share a few important housekeeping announcements. These are also available in the chat box for your reference. All attendees will be kept on mute throughout the session by default. Kindly post your questions in Q&A tab for conference tool of the conference tool. This will be taken up during the Q&A session. Questions in the chat box will not be entertained. If you want to enlarge the presentation, please click on the expanding arrow icon at the top right of the presentation screen. The tool is configured for HD video. You may switch to LD in case you are facing any bandwidth problems. Attendees may like to visit the exhibit booth of the TSTSI in between the sessions to know more about our work. Attendees can use the lounge facility for networking. The lounge will remain open till the end of the conference. The conference sessions are being recorded and will be posted to the TTDD website in next few days. Now, I would like to introduce our session convener, Mr. Vijay Madan. Mr. Madan is currently associated with TSDSI as advisor and mentor with a special focus on standardization in services and solutions relating to evolving technologies and applications, vertical sector use cases, security and crypto, IoT, drone services, cloud computing, PPDR, future ICT enabling systems, also with JWG's focus connected with 1M2M 3GPP and ITUT. May I now request you, welcome Mr. Madan. Now, may I now request you to kindly take the floor and introduce our session co-chairs. Over to you, sir.
Thank you very much, Chandrakanta, and welcome all the distinguished speakers, panelists, chairs, and the audience in this session. We have an interesting session, and it is AI native 6G and related issues. Now, I have the pleasure of introducing our co-chairs, Dr. Hemant, who's a senior member of IEEE, and he's a very learned doctorate from IIT Bombay, and Odisha, Vasud Burla. He has more than 28 years of experience in academic research and industry. And I'm going to add, he has got a lot of experience about standards and TSDSI besides the technology. We have another distinguished chair, Jesumaria Anthony is a seasoned data and AI solution architect. This is the subject itself, and the Chief Technology Officer at Tata Elxsi, driving innovation across data science, AI, and digital platform. Very apt chair for this session. Now I hand over to Jesu and to continue the session for the speakers. Thank you.
Thank you, Madan sir.
Sir, I will need someone. तो वो सोनाली पता नहीं IIT में है या अपने ऑफिस में है.
Can we move? Thank you. Hi everyone. Good evening and a very warm welcome to the session 2 of the TTD 2026 AI Native 6G. It is a privilege to co-chair this session under the broader theme of shaping the next decade of telecommunications, 6G standards, systems, and cross-sector synergies. This session brings together the perspectives from academia, industry, standard bodies, research institutions, and vertical domains to examine one of the most defining questions of the future of telecommunication. How do we make 6G truly AI native? Ma'am, we can go to the next slide. The subject of this AI in 6G was an important part of the discussion in the previous edition of TTDD 2025, where the focus was on unlocking futuristic applications and hyper experiences. Those discussions help establish the vision, a future where networks are not just faster or more connected, but intelligent, adaptive, immersive, sustainable, and deeply integrated with the digital services. Today, as 6G moves from vision to implementation architecture, standardization priorities, deployment models, and future specifications, the question is no longer whether AI will be part of the network, that is already clear. The real question is how deeply, how natively, and how responsibly should AI be embodied or embedded into the 6G ecosystem. AI native 6G represents a paradigm shift. It's not simply about adding AI as an optimization layer on top of the existing networks. It's about designing networks where intelligence is built into the architecture from beginning across radio, core, transport, orchestration, operations, application, and services. This means looking at AI from multiple dimensions. Two complementary pathways that deserve particular attention. The first is the cross-domain data sharing and federated AI pipelines. Future networks will need trusted mechanism for data sharing across domains, operators, verticals, cloud, edge, and devices, while respecting the privacy, security, sovereignty, and governance requirements. The second is the AI native architecture and applications. This includes intelligent network architecture, digital twins, agentic operations, knowledge graphs, autonomous lifecycle management, and AI-enabled vertical applications across sectors. Both pathways are deeply connected. AI native architecture needs high-quality, contextual, governed data. At the same time, federated data ecosystem need intelligent, secure, and standards-aligned network foundations. This is where 6G becomes more than a communication system. It becomes an intelligent platform. Today's session is designed to bring out these complementary views through keynote perspective and a structured panel debate. We will hear who bring deep experience across technology standards, research, deployments, and vertical applications. The objective is not only to discuss possibilities, but also identify actionable priorities for architecture, standardization, collaboration, and implementation. With this context, let's begin this important discussion on AI native 6G, from vision to architecture, from architecture to standards, and from standards to real-world impact. Thank you, and I look forward for an insightful, action-oriented session. So this is the agenda that we have for today. We will have an three keynotes. Keynote 1 towards AI-driven RF semantics from Professor Sundar Vanka from IIT Hyderabad. Keynote 2, 6G cognitive networks, agentic AI, digital twins, and knowledge graphs from Mr. Jnana Prakash Sebastian from Data Alexi. Keynote 3, earning AI native 6G from Mr. Aditya Chaudhary, Advaya Networks. And we followed by a deeper panel discussion that will be hosted by Mr. Hemant Rath from TCS, and we'll try to follow the schedule, and there will be a time limit that will be given for each of them, and we'll follow it and hope we will have a enriching journey here actually. Ma'am, we can go to the next slide. Yeah. AI native 6G starts at the radio layer. Instead of merely detecting signals and spectrum usage, future networks should understand the meaning of and context of the RF environments, enabling semantic awareness of the wireless scenes. The first keynote is on the topic towards AI-driven RF semantics, which will be given by our Professor Sundar Vanka from IIT Hyderabad. A small gist of the profile of Mr. Professor Sundar Vanka. He's an associate professor in the Department of Electrical Engineering at Indian Institute of Technology, Hyderabad. He's an inventor of 13 US patents, 1 book chapter, 5 international journal publications, and 11 international conference publications, and multiple invited talks in the US and in India. We welcome you, sir. I would leave the next 20 minutes for Professor Sundar Vanka to take over the stage and go through the keynote, sir. Thank you.
Thank you very much, Mr. Jesu, for the kind introduction. Let me share my screen. I hope my screen is visible.
You can go to the presenter view, sir.
Yeah, let me do slideshow. Did I not?
No, it's still in the view, sir.
You're not able to see? That's
no,
not
we're
what I
see,
had
but
in
it's
mind.
not in the presenter view, actually.
Oh, so is my screen visible?
Yes, sir. Your screen is visible. Yes.
Yeah, so I'm presenting, I don't see that content in the slide here.
Chandrakala ma'am, can we present and sir, if you're having a sharing.
Yeah, I'm not able to see. For example, the first slide, it says presentation title, right? Below
So
orange.
can you please unshare your screen, sir? I will be
Yes.
sharing on my own.
We can share, sir. Chandrakala ma'am, we can share what we have.
Yes.
Thank you.
Yes, please. Yes, go ahead. Yeah. Yeah, very good. Yeah, thank you. Let me just maximize my screen.
Please go ahead, sir.
Yeah. Yes. So first of all, it's very nice to be at the TSDSI Tech Dive. It's a very erudite panel that I'm seeing and a very connected audience. It's been a great pleasure to come here. I thank the chairs for inviting me over. So today I will talk about some of our recent work on the topic of RF semantics. Okay, so this is a joint work with my colleague, Mohana, who is also from the electrical engineering department at IIT Hyderabad. So what I want to do is, next slide, please. So what I want to do is to set the stage for why we need something like that in the 6G context. Then I'll talk a little bit about some conceptual proof of concept and some of the work that we're doing. So traditionally, if you ask an RF engineer or a wireless engineer what RF sensing is, essentially we are interested in knowing who's using the spectrum. Okay, so many of us are old enough to know the so-called TV white spaces, where the idea is because the TV station has a finite RF footprint and a spatial footprint, right? You can reuse some of the you can reuse that spectrum if you are far away enough from the TV station. And you can do that either by having a scanner, which will tell you whether the TV station is strong enough, or you can have a geolocation database. So these are all well standardized, right? Because the TV stations are fixed. Okay, I'll tell you why that fixed nature comes up, in a minute, right? So now on the other side, if you look at what is happening in the ISAC community, like what is called integrated sensing and communication in the 6G context, people are trying to use essentially active sensing beams or sensing waveforms or sensing protocols to essentially do the work of sensing in the presence of mobility. So one of the key themes in 6G is these non-terrestrial networks. So what people want to do is have the ability to have situational awareness. So there's a lot of work on integrated sensing and communication. So there is always the interference between sensing and communication functionalities, and also in terms of in mutual dependence in terms of how much bandwidth you give for each task, right? So what this also means, because we're trying to develop sensing algorithms and sensing protocols, okay, we are doing this precisely because we have platforms. I mean, think of a UAV or think of an autonomous vehicle, right, that require knowledge of their local environment. Okay, so one example is, you have UAVs that typically go in convoys, right? So if I have a UAV convoy that is, let's say, doing some warehousing work, okay, and it wants to essentially make sure that its spatial highway or aerial highway, okay, is not in conflict with other UAV swarms, okay, in the vicinity. There is always a reason why you would want to have some notion of situational awareness. So there is a lot of work going on in terms of how the situational awareness can be achieved by means of talking to base station, inter UAV communication and so on, right? So remember that kind of a deconfliction mechanism requires us to actually actively send a packet to recover information about our surroundings, correct? So I'm going to put it in that bucket, correct? Now, similarly, you will have autonomous navigation, where you really need to figure out what's happening around you. And one of the things that you try to do is to actually figure out different which base station to connect and so on, correct? So and then you have an emerging use case where you have search and rescue missions, where essentially you need to figure out where individual users are, given that there is no infrastructure, correct? So the question that we want to ask is, given that traditional usages of sensing are all active, But what I mean by that is you are actually doing signaling to figure out the different locations of different objects around you, right? Whether they are actual transmitters or not, you're trying to do sensing to figure out if there's a nearby radio transmitter near you. Is there a passive approach which can actually do something which can give you some information, which is not, which is pretty much free in the sense that you don't have to use the bandwidth of the network? Okay, so that kind of led us to ask this question about, are there opportunistic ways where I can sense the RF medium and can I get more information than what I'm traditionally used to? Next thing, please. Next page, please. Yes. So because because this is offline, this is online, right? So let's try to have a picture in mind, right? So I'm giving two examples. You can pick the example that you like, right? But fundamentally, what we want is, imagine that there's a UAV that wants to have some idea of the so-called RF scene. I'll describe what it means in a minute, but let's assume that it wants to know where each transmitter is, or at least what spectrum it is going to transmit, how many distinct transmitters are around me. Okay, so that's a fundamentally different question from asking, is a particular channel busy or not? Okay, so if you take that approach, okay, the question, next slide, please. So the next approach would be, let's say you're doing you want to know in a given scene, okay, how many unique transmitters exist. So for example, let's say there's a UAV that is trying to do a search and rescue mission. And let us say it wants to know, among all the transmitters that it is seeing, okay, among all the energy, RF energy that it is seeing across different subbands, okay, which energy cluster belongs to which transmitter. So we may want to be more ambitious and ask, where are those transmitters? Okay. And if you go and ask many of our signal processing friends, they will say it is possible to do a lot of, signal processing to recover that, provided you know who's, that particular chunk of spectrum, right? And we may want to become more ambitious and ask, what protocols are those transmitters using? Okay. So essentially what we're going towards is what we like to term as RF semantics, right? So if you think of an image as your RF spectrum, where you have time versus frequency as your two, height and width, right? What exactly can you identify the different objects in the image and ensure that you know what you want to know about those objects? Okay, so that's what I'd like to call RF semantics. So we'll see that we'll see a little more details in a minute. Next slide, please. Next slide. So now here is the idea, right? So we all know that if you take a bunch of raw IQ samples, IQ is just in phase and quadrature samples. If you operate at that level, C in a real scenario will be an arbitrary looking signal. You have no clue what exactly are the signals that constitute that particular sequence of numbers, right? So what we do is a very natural thing to do in the context of RF is to essentially take a spectrogram. So what a spectrogram does is give you a slightly more granular frequency occupancy, okay, as a function of time. Okay, so imagine that you're trying to listen into your home Wi-Fi network. All of us have seen, when you want to tune into a Wi-Fi network, you will see that there are many different Wi-Fi networks on different channels. Imagine that you're listening to the entire Wi-Fi band. Okay, you will see on certain channels, certain transmitter will come, transmit for some time, and then go away, right? On some other channel, there will be a similar activity going on. So if you imagine that the whole thing looks like in a two-dimensional space, time is one axis, okay, where you imagine like time is your x-axis, and frequency or the channel number is your y-axis. You will see a lot of activity in the time frequency space, right? So what you can do is, if you treat the spectrogram as the reversible map between the IQ samples and the representation, that is the spectrogram, now we have an interesting problem, right? Can you detect individual transmissions within the spectrogram? Okay, of course. Then this is where it gets interesting. Can I form emitter level representations? Okay, by learning the latent space in which I can represent them. Okay. And more interesting is you can now extract behavioral and physical characteristics of each emitter. Each emitter, by emitter, it is each transmitter. Okay. So what you can do, I'll give an example in a few slides. But imagine that instead of trying to understand, to take an example of, let's just say, a football match, instead of trying to look at each player as just a human, as an object, okay, and you say that the ball is just one other object, okay, can I now identify all the players, okay, that, let us say, just for the fun of it, I want to know all the players who are left-handed. I want to know all the players who are right-handed. So here it would mean, in this case, for example, in our RF case, it can mean who are all the transmitters who are likely to come have a specific signature. Okay, so for example, they can be hoppers, they can be frequency hopping systems, they can be like a jammer kind of a system. So we can identify essentially the fingerprint of each emitter. Okay, so this gives us a structured understanding of the wireless scene. Okay, next slide, please.
Sir, Professor, sir, can we turn on your video also? Can you turn on your video? I think video was not turned on actually. If you're okay, we can
Okay.
see on video also.
Yeah, sure.
Yeah, thank you, sir. You
Is it on now? Yes.
I thought there was a glitch there. I just thought I'll interrupt.
No
Thank
problem.
you,
No
sir.
problem. Okay. So again, I don't want to bore you too much with the data processing pipeline. Just to have a picture in your mind as to what we're trying to do. So we have the raw IQ baseband signals, which we capture on actual hardware. And you can actually do what is called a short-time Fourier transform, which is essentially what converts a pure time domain sequence into a time frequency representation, which is called a spectrogram. We all know that. And then we have tailor-made algorithms, okay, which are all tailor-made for RF signals, where we can do a combination of object detection. So imagine that you're trying to isolate different emitters. And you're trying to, in the next step, you're trying to find out clustering the packets, which what it means is you're clustering the different emissions from the same emitter. Okay. And then you can now extract the properties of each cluster. Okay. So what you're doing as a result is not only understanding the local property of individual packets, which is what a sniffer will do. So if you anytime used a wireless sniffer, it will actually figure out, if you give a packet, it'll decode everything and tell you what the header contents are. We can first, as a pre-processing step, we can actually figure out where these objects are in the time frequency space. Okay, identify all the objects from the same emitter, which is new, which no sniffer does. Okay, and now we can even form a model for the transmitter, which is actually very exciting, right? So we have a more data-driven approach as opposed to a more model-driven approach. So next slide, please. So the main idea is what? So if you have a wireless activity in a given environment, again, you can think of your favorite abstraction. For example, imagine that you have a search and rescue mission, where you're trying to identify who are all the different emitters there and what locations they are, right? So we view this as an RF scene, which has a specific context, okay? And learn these representations, okay? Instead of trying to train, what people do in the community, in many papers, is they actually do a packet-centric representation. What it means is they train your wireless network to find that given the packet, it figures out what it is. But here we are asking, can you tell me what emitter gave it, which is actually more powerful? Because once you know what emitter gave a particular spatial signature, you can actually send that to any sniffer and you can do whatever you're doing right now. Okay. So what it means is you can now create these transmitter-centric representations. Once you have those representations, you can build richer abstractions. So you can talk about contexts for the transmitter. Okay. So you can have, for example, you can even figure out whether if you know two emitters which are probably whose behavior is sort of synchronized, you can maybe guess that those are transmitters and receivers, for example. Okay. Or you can also say, for example, that if an emitter is sort of acting anomalously, you can say that there is a problem with that emitter. Okay. So what you can do is essentially use data and essentially protocol agnostic reasoning, okay, to essentially learn about the wireless environment as you adapt. Okay. So what we have right now is a rather lightweight domain adapted model, which I'll show you the results in a minute. And what we have is a rather agnostic means to actually do this kind of identification. So we don't really worry about the specific modulation characteristics of the signal because it's all learned from data, right? And we can easily plug it into known analyzers and sniffers without serious problems, right? So the fundamental point that I want to make through this thing is that spectrum sensing, which has been considered to be a domain where essentially you figure out whether spectrum is occupied or not and try to dynamically use spectrum efficiently and so on. It has a much richer story to it. The moment you identify scenarios where situation awareness plays a big role, okay? So there are obvious implications when it comes to 6G because we do have native platforms which require such situational awareness. Okay, so next slide, please. Yes, so I just want to kind of drive home this distinction because it's important to keep that in mind. So if you look at model-based processing, so conventionally, how would you do that? You would do an energy detection algorithm. Then you would figure out by means of some thresholding, that technique that you use, what are all the parts of the spectrum that are occupied. So maybe you'll identify 2 or 3 such areas of the spectrum. And then you go with these heuristics to figure out, what those transmitters are, what should you look at. And you may even have handcrafted features to figure out what those transmitters are and maybe do some similarity check, right? So at the end of the day, you come up with a decision rule that is built on heuristics. What we are saying is you don't need that kind of an approach because there is a cleaner approach, which is more adaptable to data-driven approaches, which is learning the representation, okay, in real time, okay, and representing each emitter. And therefore, you now have a scene, RF scene, which is completely represented, okay? Now you can ask, that leads us towards questions on RF semantics. So next slide, please. Yeah, so I hope this will kind of make things a little clearer. So what I'm going to describe here is some of the early work that we have done with very simple USRE, just to show some proof of concept. We're trying to now implement this on drones. So what you have here is we have a passive receiver. Like I said, this is our stand-in, our USRP board that you see on the left picture. That is your USRP board. And that is actually passively listening. It is not sending anything. Okay, so it doesn't disturb the network in any way. And what we have are multiple wireless devices that is doing its own thing. They don't even interact with each other. So you have, for example, a Wi-Fi network, which is maybe exemplified by one of the access points shown here in magenta circle to the right. And then you can have one or more laptops. For example, you can have a laptop in black that is shown right next to the access point, or you may have a laptop that is slightly farther away that is connected to another access point, maybe on the ceiling or something, right? And then here I did not show the Bluetooth, but the Bluetooth was, you can stream music. So probably my student was hooking up the Bluetooth to it. Okay. So what we have is multiple radio devices that are occupying the same environment. Okay. So if you next slide, please. So we took a trace given a certain sampling bandwidth. Okay. So what do you see here? So this is a great example of what I mean by RFC. So yeah. So if you take, for example, the top left, okay, so all these are essentially spectrograms. The time axis is on the x-axis. So this one comes out to be about 50 milliseconds long. Okay, right? And it is about 80 megahertz wide. Okay, so now what we've done here is the light green packets are all Wi-Fi packets. We have essentially, in this case, initiated a ping session. So the Wi-Fi device is just pinging and it's, getting packets back and forth, right? And it is, then you have these other smaller yellow packets, which are all Bluetooth packets. So somehow he stopped the transmission in the middle. So what and you have these 3 cases, right? Let's see the other case, right? This case, you have 2 Wi-Fi emitters, okay? And you have a Bluetooth device. So the 2 Wi-Fi emitters are the one which is centered at around 20, the other is centered at around -20. As you know, Wi-Fi bandwidth is about 20 megahertz, right? So similarly, again, you have the other case where you have a lot more Bluetooth activity along with this Wi-Fi activity. And then you have the last case where you have a single Wi-Fi packet, single Wi-Fi network, but you have multiple emitters that are talking. So imagine that, if you go back, can you go back please, one slide? So the last slide, bottom right, can mean, for example, the magenta access point is probably talking to the red laptop. And maybe this red laptop is talking to another Wi-Fi, which is maybe situated outside this picture. Okay, so you have two Wi-Fi networks. Yeah, please go ahead. Next slide, please. Okay, so what this is trying to do, this slide is capturing what our model predicted as the locations of the transmitters. So if you see here, the red boxes that you see around all these transmitters refer to the bounding boxes of the object detection algorithm, okay, that we used. And you can see in the middle, you see these small numbers. Those are the confidence levels, right? So you see that in these cases, you're able to reasonably predict where these emitters are, and also try to predict, with reasonable confidence. Okay, in all these cases,
Professor, this is
yes,
just a gentle reminder. We are almost at the 20th minute, so
yeah, I'll be done in a minute. Yes, thanks for the reminder.
Thank you, sir. Just a reminder, actually.
Yeah, thank you. I'll be done. Yeah, thanks. So next slide, please. Yeah, so this is just to tell you that you can actually cluster them. So I just wanted to show you that you can actually say that all these emitters were classified as one color. So you see in the top left, all the Wi-Fi emitters were transmitted as classified as one color. The Bluetooth were transmitted as a different color. Again, to the top right, you'll see all the orange emitters, orange colored tiles are one color. These color tiles are another color. The light green, another, similarly Bluetooth and so on, right? So the interesting thing is this also works on a single channel. So if you see the bottom right, you will see two blue and one white. And why is that able to do it? Because it is able to check the emitter signature. So it is not only about finding the distance and the RSSI, right? It actually found the emitter signature. Okay. So next slide, please. So of course, once you get this data, you can actually extract statistics, right? So you can get from individual packets, you can figure out the center frequency, estimated what is the bandwidth of the packet. You can get all kinds of data that you can use. Okay, this is just a point. Next slide, please. So here, for example, we have identified two clusters in this example. I've taken the top left example that I showed you. So you have one Wi-Fi and one Bluetooth cluster, and it gave you duty cycle, it gave you bandwidth, center frequency, and so on. So you can, you can obviously do more with it once you have more data. Next slide, please. So similarly, you have the same thing for the other case also. Next slide. Next slide. So I'll skip this in the interest of time. So the main takeaways that I want to tell you is for RF semantics, it's important to think in terms of RF scenes. Okay. And we can use AI to develop a very hierarchical representation of this RF scene from IQ samples. And we've been able to develop these domain native AI designs that I'll be happy to discuss with any of the people offline. And so our models are actually tailored for RF. So it's not that we just plugged in something and got it, right? So that's something that we were able to do. So to me, this is a very interesting sort of very side to RF based machine learning. Can you go to the next slide, please? This concludes my talk. So I'd be happy to take any questions.
Thank you, Professor Sundar. And sir, there are two questions on the chat. Maybe if there is someone who has a question, you can ask, or sir, you can also answer through the chat, sir. There is a couple of questions on technical details that I see. Maybe you can answer through the chat also.
So I can, should I answer on chat or should I answer verbally?
Verbally also possible, sir. Whichever.
Verbally, I'll answer verbally.
Possibly, if you can answer on the chat, please. Thank you.
No problem. So
sure.
Yeah. So
chat offline, and then some next speaker can be.
Yes,
so chat. Okay, so I'll just answer it verbally and just quickly go into the next one. So for software, we are using our data is all custom, right? So we basically get data using our own custom Python scripts that we wrote. Okay, so that's actually quite straightforward. And what all parameters do you take for identifying the emitter signatures? That is learned by the model. Okay, so that's a very technical discussion. I'll be happy to engage with them offline. Okay.
Thank you. Thank you so much, sir.
Yeah, thank you.
So this keynote illustrates how AI becomes native to the AR interface itself, enabling autonomous navigation, some interesting things on UAV coordination, end-to-end operations, search and rescue, and context-aware radio intelligence. It demonstrates that intelligence must begin at the RF layer rather than be added after network data is collected. AI native 6G begins with semantic understanding of the wireless environment, enabling radios to understand context rather than merely detect signals. This brings us to the next speaker, Mr. Prakash Sebastian. Prakash Sebastian is a principal architect at Tata Elxsi CTO office, driving AI-first architecture and innovation for the next generation telco platforms. The title of the keynote is 6G Cognitive Networks, Agentic AI, Digital Twins, and Knowledge Graphs. AI native 6G is not a feature, it's an architecture paradigm built upon three complementary pillars: AI embedded into networks, AI for networks, networks for AI. I now welcome our speaker, Mr. Jnana Prakash Sebastian, to deliver his keynote. Welcome you, sir. Please, you can take the floor, and the screen sharing also you can do so. Thank you.
Thanks, Jason. Thank you so much. And let me start sharing my screen. If my screen is visible.
Not at Chandrakanta ma'am can. Yes, it's coming up, sir. Yeah, it's up. You can start. Actually.
Great. So good afternoon, everyone. Thanks, Jason, for that introduction, and pleasure to be part of TSDI Technical Deep Dive Conference 2026 on the session on AI native 6G. So as Jason was alluding to, I'll be focusing my keynote on agentic AI, digital twins, and knowledge graphs in the context of 6G cognitive networks. So the key message I want to start with is the real value of 6G is when the intelligence gets embedded natively into the network architecture, as well as into the operational models, and the overall 6G infrastructure itself becoming a distributed infrastructure for the AI workloads. And that brings in a lot of values for the telcos, as also a lot of values for the various industries, various industrial vertical use cases that can run on top of it. And it is also bringing value for the nation in terms of becoming a strategic asset for the nation. So let's look at the AI native 6G through the three complementary pillars. AI native 6G is not just one single technology layer, but it's more of a combination of connected architectures across these three complementary pillars. So when we look at the first pillar, which is AI embedded into the networks, is the AI which is getting embedded into the various network domains across RAN, the RF, the core, the transport, as well as into the O&M layers as well. So in the RAN, core and transport, AI brings in various value in terms of improved efficiencies, improved performance of the network, improved customer experience out of these networks. And at the O&M layer, bringing in zero-touch operations. And one key aspect is the model lifecycle management. How do we manage the lifecycle of the models or the AI which gets into the network? How do we version control them, and so on and so forth? The second pillar is the focus for my keynote speech, which is AI for the networks, which is mainly on the operational and intelligence layer, bringing in the AI for the improving the operational efficiencies, managing the networks better, bringing in energy efficiencies, better customer experience, and so on and so forth. So this is where the agentic frameworks, agentic architectures can play an important role in not only making the AI for raising certain alerts, doing certain root cause analysis, but also the closed loop autonomy, various levels of autonomy that can be achieved, semi-autonomous with human in the loop, etc. And the third pillar is the network for AI, where the 6G 6G network itself becomes the AI infrastructure, also the distributed AI infrastructure for running various AI workloads. This can bring in values across, bringing in the ability to do edge inferencing, low latency AI use cases, and the efficient orchestration of the AI workloads across this distributed infrastructure, efficient orchestration also of the AI resources itself, GPU orchestrations, efficient use of the AI resources can lead to better energy efficiencies as well as improved AI performance as well. The sovereignty also is one key aspect or one key value that the 6G infrastructure can bring in when the catering to the government regulations, national regulations in terms of providing sovereign AI and sovereign data capabilities. So let's just quickly touch upon the telco infrastructure as a strategic AI infrastructure, as we were talking about the sovereignty and of the AI as well as the sovereignty of the data. So the telco infrastructure is not just a delivery pipe for AI, it is also the sovereign, distributed, and trusted AI infrastructure for the nation as well as for the various industries. So the various infrastructure assets of the telco, which could be across the transport, the RAN and the core, as well as the distributed data centers, the edge data centers, and the overall existing security and trust frameworks within the telco infrastructure can be viewed as an overall telco AI infrastructure fabric as the network becomes AI native with 6G, where this AI telco fabric inherently by nature is distributed. It is already trusted as a lot of enterprise business is already running on top of it. It is the backbone for providing public services, healthcare services, and so on and so forth. So the telco infrastructure with AI native is also becoming the trusted as well as the distributed as well as sovereign infrastructure. And through that, it can bring in a lot of values, the sovereign capabilities for the nation as well as for the enterprise AI to run on this trusted infrastructure, the edge inferencing capabilities we spoke about, and also with the efficient orchestration of the AI workloads and efficient orchestration of the AI resources, it can also make AI services more affordable, more inclusive, and can reach the various strata of society, be it the rural as well as some of the underserved communities. The efficient orchestration of the AI can also bring in energy efficiencies when we look at the cost of the and the energy cost of the AI itself. The trusted infrastructure for trusted data exchange in terms of federation of the data, federation of models can also be, this can play an important role there. And the various industry services, industry vertical use cases that can run on top of this infrastructure. So just extending that discussion further to look at some of the cross-industry impact that AI native 6G can bring in across various industries, across manufacturing, healthcare, agriculture, transport, as well as energy utilities. So of course, some sample industries and sample use cases mentioned here. But the key point is that with AI native 6G, not only with the improved network performance, improved capabilities of the 6G network, but also the distributed AI architecture infrastructure that it brings in can enable a lot of industry vertical use cases. And through that, it brings in monetization of opportunities for the telco as well. They can monetize not only from the connectivity, providing the service, but also monetize the distributed AI infrastructure. So with this, if we just take a look at the architectural blueprint for an agentic AI operations platform. So with all of these values that the AI native 6G can bring in, how do we manage this AI network, AI native telco network across the RAN, core, and transport? So the architecture blueprint which shows at the bottom the AI native telco network, which includes the 4G, 5G legacy systems as well as the 6G RAN, core, and transport. And alongside it, or you can look at it as below that, is the distributed AI backbone across the edge data centers, the local data centers, the regional as well as national data centers. This distributed backbone gives the ability to run AI workloads efficiently. So maybe for certain low latency ML inferencing, tiny LLMs or domain specific models can run at the edge to get better performance from the AI applications. For certain model training, where higher resources needed, it could be at the local or regional data centers or central data centers. Telco SLMs potentially could run at the local or regional data centers, whereas generic LLMs might run at the central or national data centers. So the overall architecture, one of the key layers of the architecture is the digital twin layer. Would like to start with that, where we see digital twins across the different domains for the access, the transport, as well as the core. So we look at domain-specific digital twins here, but the digital twins could also be across the services, where there could be service digital twins, which are across domains. There could be infra-level digital twins for the distributed AI backbones and so on and so forth. So within the domain-specific digital twins brings in the capabilities to sync to the network and maintain the current state of the network, as well as it can also provide the historical state of the network. The behavioral models which are on top of these digital twins can give the ability to model the behavior of the network components. And typically these behaviors could be also vendor specific, the telco ecosystem being quite complex, multi-vendor ecosystem. There could be vendor specific behavior models that are developed. And through that, it gives the ability to do certain simulations, what if analysis, impact analysis for any of the actions. So this is a key capability which needs to be built into the overall architecture. And top of it are the various domain specific or vendor specific ML models, which will be typically needed for the network data analytics. The various agents, the multi-vendor as well as multi-domain agents, leverage the ML models for the analytics part of it, as well as they leverage the LLMs or the telco SLMs for token economies, for doing the decision making, for reasoning part of it. So all of this is tied together using the multi-domain ontology, which gives the semantic layer or semantic reasoning layer. So it's not just the various network nodes which are getting represented or the data of the nodes, but the relationships or the semantic relationships between the network nodes, between the data that is leveraged by the agents to do their efficient, automation. On top of the agents is a multi-agent orchestrator, which basically orchestrates the underlying agents. This could be for a specific domain, or it could be across domains, where the multi-agent orchestrator understands certain low-level intents and then basically orchestrates the agents to fulfill that low-level intent. There's an intent orchestrator for translation of all the high-level intents, which could be business intents, service intents, to sub-intents or low-level network intents or resource-level intents, which can then be orchestrated by the multi-agent orchestrator and the various agents to fulfill that intent. So on the top, we see the various possible intents that can be there. There could be customer experience related intents, there could be operations related intents, as well as monetization intents. So the overall aim of the architecture is not only to improve the customer experience, improve the network performance, but also improve the operations of the network or operational efficiency of the networks, and also to bring in the ability for the telcos to monetize this network through monetization intents, which could be slice intents, it could be any other kind of monetization intents here. All of this, of course, getting governed through the AI governance, the necessary guardrails for the agents to work, the necessary policies which drive the agent actions, and so on and so forth, and the security across the various layers of the architecture in terms of access level security up to the data security as well. So just to reiterate on the fact that the digital twins and knowledge graphs bring in the foundational capabilities or foundational enablers for agentic AI operations, where the digital twin becomes the trusted decision sandbox for the autonomous agents to learn, simulate, and validate. So this is a key aspect, especially when we see some of the challenges in today's AI adoption is the trustability on the autonomous actions of these agents, the ability to validate these actions on a sandbox environment, uh, to validate the impact of the actions before they are getting applied to the network. So that brings in the additional trust layer into the actions of these agents. So the capabilities that the digital twin needs to bring in terms of the ability to sync to the network and have a real-time replica of the network and becoming the overall execution framework or fabric for the agents to work on top of it, and the simulation capabilities where it can have the ability to define certain scenarios, define various configuration templates uh, where the behavioral models can be utilized to study the impact. There could be an element of model chaining required where complex scenarios being involved, multiple models to be chained together to actually do that full intent, a full impact analysis there. On the knowledge graph side, as we say, the twin becomes the live network brain map, but the knowledge graph brings in the semantics for understanding the relationship between the nodes, relationship between the data, which is critical for the agents to also take actions on top of it. So it becomes the context engine for the agents in terms of not only the live state of the network, but also the relationships and the various semantics for the agents to take appropriate actions. It brings in capability also to do better RCAs, especially when we are talking about root cause analysis within a specific domain to analyze what would be the root cause for a specific network alarm which has been raised within the network, as well as cross-domain root cause analysis to better correlate alarms, better correlate issues which are occurring in the network to identify in which domain was the root cause which caused impact to occur in a different domain, for example.
Prakash, actually, another 5 minutes left, just
Yeah.
remaining the time check.
Sure. Thanks, Jesu, for that. I'll quickly wind up. So just listing down some of the key challenges that we see in AI adoption today in telecom. These are the challenges potentially we need to keep in mind when we define the architectures for the AI native 6G to see how these can be overcome as part of the AI native 6G. The key technology and operational challenges being the fragmented and disparate systems within the telco environment, the multi-vendor nature of the environment. There is a lot of inventory mismatches, topology quality is not that great today in the telco environment. So how this can be addressed as part of the architecture within the 6G, we need to look at it. And also on the trust and governance angle to bring in the necessary checks and balances on the explainability, auditability of the AI, bring in the human in the loop aspects, and also to ensure that the architectures are also catering to the data and AI sovereignty regulations which come in from the government. Some potential priority areas and takeaways for TSDSI in terms of architectures, standardization as well as deployment, where the architectures need to be defined, reference architectures potentially for some of these intelligence layers that we are talking about, and how do we have certain open APIs, interface standardized APIs, so that there can be more federation, more data sharing, more domain share, model sharing, capabilities within this architecture. Maybe new KPIs need to be defined when we look at AI capabilities, maybe some energy or AI level KPIs that need to be there in place to monitor the AI as well as to monitor the energy efficiency part of it. And also on the deployment side to bring in the necessary trustability angles, the lifecycle management of the AI models need to be looked at, potentially the current problems of multi-vendor integration, and then the ability to bring in sovereign deployments as well. So with that, I would like to conclude the presentation. Thank you everyone for your time, and just to reiterate that AI native 6G brings in a lot of benefits, a lot of values, as we have seen, but there are a lot of challenges also which are present in terms of the AI adoption and the role that TSDSI can play in driving certain standardizations to overcome some of these challenges in terms of the availability of the data, whether there can be influencing options for the government policies to be in place for data federation or model federation, more standardization on the data sets, the KPIs that can be standardized. These are the opportunities that I see for TSDSI. So thank you, everyone.
Thank you, Prakash.
So,
Thank you, Prakash. Mr. Prakash, actually.
yeah.
Prakash, there is a couple of
Are there any
questions on Q&A. There is a question from Prajita, but the question is kind of truncated. Maybe Prajit, if you can ask, we can get it addressed to Prakash, or Prakash, you can answer through chat actually if the candidate is not speaking here actually. Prajit, and there is one question from
Sure,
Pradyuman.
Jason, maybe you know, answer offline.
Yeah, you can answer offline. Yes, yes, please. Thank you. Yes, I think this keynote actually brought 6G, that 6G will become the intelligence fabric for entire industry, enabling applications across manufacturing, healthcare, transportation, agriculture, energy, and telco operations. This keynote provides perhaps the closest definition of AI native 6G architecture. The intelligence we heard about intelligence embedded network functions, agentic AI managing operations, digital twins that enable safe simulations, knowledge graphs that enable reasoning for the AI, sovereign AI infrastructure enabling national scale AI services. I think we also saw we're saying AI native 6G equals intelligent architecture plus agentic operations plus distributed AI infrastructure actually. Thank you, Prakash, sir, for the keynote. I now like to bring in the third keynote of today, which is on the topic of earning AI native 6G. We have with us our speaker, Mr. Aditya Chaudhary from Advaya Networks. A small brief intro about Aditya Chaudhary sir is like he's a telecommunications and digital technology leader with nearly 4 decades of experience. He's the founder, managing director, and chief technology officer of Advaya Networks, where he focuses on integrating artificial intelligence into next generation telco networks. AI native 6G cannot be designed in isolation. It must be earned through standards, interoperability, and real-world deployment across existing multi-vendor telco environments. This keynote kind of addresses that and helps us deep dive into it. I would like to welcome our beloved Mr. Aditya Chaudhary to take the floor and walk us through the keynote, sir. Thank you. Thank you. Well, we welcome you, sir. Thank you.
Thank you, Jesu. Okay. Grateful. And thank you for your time, ladies and gentlemen. You will have questions by the time I end. And I will appreciate if you can put those questions in the chat. I will learn from you, you will learn from me, and we'll have, the next 15 minutes of a good journey together. There's been a session 1 where the operator, the OEM have presented a view. We've had sessions here where the different views being presented. I come in because of my background with a slightly different view, which I like to present to you. Happy to take questions and prove that I am not quite correct, but let's have that conversation. Next slide, please. If you're sharing my screen, thank you. Now, there's a lot of debate right now on AI native network for AI. But I think the question is not exactly whether AI is coming. My view is AI is already in the network. Now, how deeply is the question? So give you an example very quickly. The SONs which have been given by the OEMs to do a lot of work on the RAN side have a lot of AI. They're rule-based SONs and now they're ML-based SONs. So the vendors themselves are putting in AI to manage the current 4G and 5G networks. Third-party SONs Many of them are rule-based, many of them are ML-based. So the AI ML piece is already sitting inside the network. If you go back and look at the transmission, the large backbone of the network, there's a lot of AI ML being used by operators who are in this arena. You just do a Google search, you'll find, yes, they have, apart from routing and other pieces of work, they've started putting in AI ML to be able to learn. So one thing is very clear. So when 6G comes, let us assume 6G comes 2030, first set of RAN equipment comes in. I don't think operators, 650 operators around the world are going to throw away the 4G, 5G networks. It'll come in, there'll be some portion of 6G, it'll maybe land in the urban areas first before it starts moving around like what happened for 5G. And therefore, there will be years of coexistence. Will it work like, will we drop it, some parts of technology like 3G? I don't know. But the reason you need to look at this carefully is, the two differences, major differences, or three major differences is latency, the second is throughput, and third is availability. Availability from 5 nines for 6G is supposed to go to 5 nines to about 7 nines or 9 nines. 99.99999% availability is what is being designed for. And it is going to be multi-technology, which means there'll be satellite networks. And so my view, it's already AI is in, is just that, what do we do about it? The next slide, please. Now, many of my colleagues have been putting multiple columns into trying to explain this. Sean Kelly from Nokia in the earlier blocks had almost 3 blocks in just the RAN side of AI. The earlier presenter had 3 slides again on the telecom side. But my view of AI is slightly different, and I'm taking a backseat, generalizing. You have AI in the network. So whether you have AI for RAN, AI, RAN for AI, or whatever else you want to do it, it is all a part of the telco, inside a telecom company, inside the operator. That is one piece. So you're running multiple operations. And why will a telco run it? So somebody on the chat had asked, we are at TM2, 3. No, some of the songs get to TM4. Some out of 9 actions, 3 of the actions go on TM5 as well, without human in the loop. But yes, you're right. Many things are rule-based. So without human in the loop, even today, we don't look at automation. So that is one piece. And AI in the network is basically a business decision of what outcome it gives to the telco. Does it reduce the cost? Does it improve availability? Are you able to monetize better? Because remember, putting AI in the network is a cost. A simple example, one GPU on a radio or RAN will increase power consumption, and this is a report, by 7 to 10%. So while everybody is trying to reduce cost of the network in terms of efficiency, and we want to reduce the cost of energy, putting a small GPU will increase the cost of RAN in terms of OPEX by 7 to 10%. So the AI in the network is very dependent on what the outcome it will give. While the industry will move, which is moving, it's like the software industry. You can go back and do a lot of coding using AI, but will it take away the lives of all engineers? I don't think so. The roles will change. In the similar state, the telco will modify, will change, will evolve, but it depends on the business case. On the other side, it's a very interesting thing that the network has to be for AI. Today, if you run just a speed test right now, and ping what speeds you get, on a 5G with 2 different operators, what I get is about 15:1 or 10:2, which means 10 times is the speed of the download, 2 times is the speed of the up. The other one is also same. It's giving higher speed, but the download speed, the upload is gone. Now, why is this important? Because the entire networks that were designed till now were for downloads, OTT players, CDNs, etc. When you get AI in, when you want to go back and upload images, screens, etc., which will happen in the upload area, you will need a higher uplink speed. Where does that come from? Do we require it all the time? No. It is required when there is extra traffic. AI is required then to be able to sense behavior of users and then to be able to change the network almost on the fly. The reason I'm using almost because there are some actions which will happen near real time and some actions will happen real time. So that's why there's a distinction between what is required as a requirement. So the other piece which is very interesting is that not only you have multiple vendors in the entire network, you also have multiple technologies. In India, for example, 3 of the operators are still on 2G. About 20-25% of voice traffic is still on 2G. It may never be, managed by an AI, but multiple technologies will exist. They will coexist, and there are multiple vendors. And that is why we need to go back and look at what needs to be standardized. The next slide, please. Now, there's work happening in standardization. Everybody is aware of this, so I won't waste time. But my only contention, which is a question to this team and others who are working this area, the requirement window is in this space, in the time, for the next about maximum 12 to 18 months. After that, the standards are locked. People go back and start developing equipment, which they have not been doing. 2030, the first set of equipment will come out. If we do not go back and put our requirements in, which are specifications specifically for large portions of the world. So imagine India, China, having one of the largest populations, if you add Africa, etc., we're looking at almost 50% of the world's population. The reason why these standards and the specifications will need to be tailored so that they can handle what India, South Asia, Africa needs. Most of the times, the technology that we've used in the past has been built, and then we have tried to deploy it and try to organize ourselves around it. And I'll give you an example where it doesn't work quite effectively. And I will also explain to you why this becomes important, this time frame in slide 7. Next slide, please. Now, the speakers before me have been speaking of various uses of AI. Fair point, absolutely fair, and I agree with them. But having run a telco, one of the problems has been where do you invest and why, and what gains that you get. There is the requirements which will be pushed back by operators by saying we don't require it. Many people who are building equipment will say we don't need it, or will have their own mechanism of implementing it. But if you go back and look at us an industry, the challenge that you have for AI, specifically for AI, when you're looking at so-called API interfaces, when you're looking at LLMs, you're looking at inference, is the multi-agent, cross-vendor, multi-technology needs to be defined. For the simple reason, 6G will not exist alone. You will not one day on 2031 wake up one day and say everything is 6G. That will not happen. So you will need to go back, define the specification of what your equipment will use, how effective it can be, and to work it through. Next slide, please. An example, fixed wireless access. Very simple example. In India, about 200 or 300 million people are without broadband. 20 to 25,000 villages are without telecom connectivity. What we need in FWA as a specification now is one, faster uplink. This is required because if you have done your speed test by now, you'll require, yes, the download is, but if you go back and look at applications which are based on AI, you'll require uplink. Second is you require a backhaul without fiber. We're 40% fiberized. I don't think we'll be 70, 80% fiberized. So this needs to work on a back end, which is microwave. Can't be satellite, will be too expensive. Today, if you work a business case, it works out to be 20 years. No operator wants to go and put FWA for villages. So we need to go back and have a specification which requires a bit of AI because you need to coordinate the uplink and then state that this is what is required for countries like us for FWA to lower the cost, work on solar, give a backhaul. And there is an AI component. That's why I use this example because it is firmly embedded into how the network would operate. The next slide, please. Now, this is a very important slide for everybody to understand because it's almost like the tail wags the elephant. The entire economy of telcos, the entire revenues is about $2 trillion, divided between 78% wireless and about 22% wireline. The B2C is about 41% and B2B is 59%. This is the telco space. The RAN, the radio piece is just $40 billion. It is hovering between 38 billion to 45 billion. I've used a figure of 40 billion. It's roughly 1.4% of this entire economy. The network piece, the other parts of the network is $290 billion. The devices, trust me, is $580 billion. So the RAN specifications are what define the devices, $580 billion. So the reason why the AI piece for RAN becomes important because it will define how the $290 billion and the $580 billion will get spent. Your phone, somebody in one of the sessions had asked the question, will these 5G phones be thrown away or something will happen? No, they will coexist for some time and so forth. But the reason why that piece becomes important is because it is the tail wagging the entire elephant. The next slide, please. Now, the question, and there's a good panel discussion. So my question to the panel is that India has done some very specific work in IMT 2020, 2030. There's an opportunity for us to be able to define the standards for a large population of the world. The users of the world sitting across Africa, India, and other places. While most of the work that happens in terms of building of the equipment, etc., happens outside the country. But that doesn't matter. For us, it makes no difference as long as we can put our specifications and our requirements in to be able to work this through. The next slide, please. Now, my question to the panel, which will come in, and I want to throw this question open to them, is, federated learning across operators, multi-agent methods, benches, etc., DPDP Act, etc., are all conversations to have. The industry, we have to look at the cross-vendor, cross-technology interfaces. How will we make this happen? The verticals. There were a lot of use cases. I mean, one of the use cases that I thought was a remote village where a 6G using some kind of an FWA technology, the teacher sits in Patna or somewhere, and in the Northeast, we can teach students and run 6 hours of classes because the teacher can't go every day and no teacher wants to go and stay in a village. Some other applications like that. What are those which will hold up, which will require lower latency, very high throughput, so that those could be specified and, we could work our specs around it. And the government obviously did a lot of work. Bharat 6G Alliance, TD8F, the TSTSI. and I will leave this question back to them. What are the requirements that we want to take there? The window is open, but there's a prioritization. This is very important that we need to sit back and prioritize what we need to do. The last slide, please.
Mr.
So,
Time 6,
thank-
5 minutes left. I think you are on target.
No,
Thank
I'm
you.
done. I'm done. Thank you very much. My only question to the panel and to the audience is we will need to earn the AI native 6G in the network that we run. I mean, we can theorize, we can talk about it, but if you go back to an operator and ask him, they will say we will do parts of it as long as there's a balance of investment for AI and the infrastructure. It's like the SON. Take the stake of the SON. You have got SON for 5G. There's not too much of SON for 4G. It's a lot of NMS, etc. A lot of tooling has been done. So suddenly when you want to do root cause analysis, somebody said root cause analysis. Root cause analysis is a very good area because it does logical reason. But how do you handle drift? How do you handle federated learning? No telco will allow you to look at their network data to be able to do this. Each telco would want to do. So that's one question, how to do it. And if we get our requirements in early, then we let the technology, dictate. Most of the times in most standards, we have allowed the technology to go back and dictate what the requirement is. While the requirements have come from some parts of the world, they haven't come from the entire globe. So there's some things that we need to do slightly differently this time. Put our requirements in and work this through. My only urge to the colleagues is the window is open now because the time frame is short, 12 to 18 months. Can we shape it together for ourselves and for the rest of the world? Thank you. Just so I'm done.
Yeah, thank you, sir. Thank you, sir. I was trying to unmute myself. Yeah, thank you so much. Yeah, any Q&A questions that somebody wants to ask, Professor? Sorry, sir, Aditya, please to ask. Sir, or you can alternatively take it through the chat, sir. People are asking questions through the chat. Yeah. Thank you so much, sir, for the time. So AI native 6G will be won not by technology alone, but by defining interoperable requirements and standards early enough to shape the global ecosystem. While the first keynote explained how AI understands the radio environment, and the second keynote explained how AI operates networks, this third keynote explained us how AI native 6G becomes reality through standards and commercialization. Through the keynote speakers described AI native 6G as a transition from intelligent radios to autonomous cognitive networks to globally standardized and interoperable digital infrastructure. The common message is clear. 6G is not merely a communications network. It's evolving into a distributed intelligence platform that will power future industries, applications, and sovereign AI systems. So those are the three keynotes that we had planned for today. I would now pass on the baton to my co-chair, Hemant sir, actually. Hemant sir, over to you. Ma'am, we can go to the next slide. Yes. Thank you.
Thank you, Ishu. Yeah, we can start. Thank you. Ma'am, we'll go to next slide, please. Yeah. Let me introduce the team. Thanks, Ishu sir, and thanks, TSD side. Hello, good evening to all. On behalf of the organizing team and TSD side, we'll have like an extended panel session now. The theme of the panel is towards an AI native 6G to transform the application. So far, we have listened three keynote talks, one on the RF aspects and second one on the agentic AI and a lot on the digital twin and other things. And third one is very interesting. All the three were very interesting on the application aspects, etc. We now need to take forward and connect the dots and see like how are we taking to the next stage. We have a energetic panel with 5 panelists, not 6, because Professor Joshna Bapat couldn't join due to some medical reason. We have Abhishek Thakur, Thakur from IDRBT, and Mr. Amit Kumar Srivastava from TEC, and two academicians, Professor Neena Govers and Dr. Sudhanshu Shekhar Singh, and we have Binos James from Qualcomm. Yeah. Next slide, please. Yeah. Let me introduce the panelists also, quickly introduce Mr. Abhishek Thakur from IDRBT. He is a technology leader, researcher, and innovator with expertise in telecommunications, digital infrastructure, financial technology, cloud computing, and emerging network technology. And he will bring the business aspects as well as the vertical aspects to this particular panel. Next slide, please. We have Mr. Amit Kumar Srivastava from TEC. He joined DOT as ITS officer in 1996 and worked at various places in India and having more than 26 years of experience in various fields of communications. He is presently heading the mobile technology division of DGM in Telecommunications Engineering Center. We think that he will also bring the aspects of government as well as aspects of the startups and other things while discussing in the panel discussions. Next panel, please. Yeah, Joshna Bapat is not there, but she is a distinguished professor from IIIT Bangalore. Yeah, next slide. We have Professor Neena Goves. She is from BITS Pilani, KK Birla Goa campus. She is a professor in the Department of Computer Science and Information Systems there, and she has been instrumental in advanced interdisciplinary research spanning computer science, embedded systems, artificial intelligence, and network systems. Yeah, we have one more academician. Next slide, please. Professor Sudhanshu Shekhar Singh. He has received a PhD in engineering from Jadavpur University and ME from NIT Rourkela. He has been working with in academia and other roles for more than 30 years. He has several publications, more than 100 publications, and has guided several researchers, 28 PG theses and 7 PhD theses. He's from KIT University of Bhubaneswar. So we have academicians from Western India and Eastern India, and we have one more speaker also for this panel. Next, Mr. Binos James. He joined Qualcomm in 2011 and has served over years roles of spanning technology and standardizations. He has responsibility for Qualcomm standardization engagements in India and Southeast Asia. He is quite active in TSDSA also. He is an expert in technologies with years of experience in product regulations. He holds PhD from IIT Madras. So we have almost 45 to 50 minutes in the next for the discussions. We plan to bring several key points for discussions, which are aligned with the theme of the workshop as well as the panel discussion topic. While we'd like to invite each panelist to speak on a particular point and share his or her thoughts with all, we like to request other panelists to share their thoughts as well while they speak during that turn. The AI native 6G represents a paradigm shift from AI-enabled networks to networks where intelligence is embedded in every layer of the communication stack, enabling autonomous operations, intelligent services, distributed AI infrastructure, and transformative applications spanning industry, healthcare, transportation, smart cities, and digital societies. There are several applications we had in the previous session also. Manufacturing 5.0, that then we have healthcare, transportations, mobility, smart cities, agriculture, banking and finance, etc. So many things are there. So we would like to start with Mr. Abhishek Thakur. The first question to him, what is the role plays of AI and 6G in your opinion, sir?
Thank you. It's a pleasure to be part of the panel, and it was a pleasure to also listen to the keynotes. So bringing in the verticals perspective, and we know that there are, while I am from banking and financial services, there are more compelling scenarios from transportation and logistics sector, be it B2B and similar, or asset tracking, healthcare, especially with respect to haptics and similar. And then smart factories are scenarios that we are seeing successfully even today, where business requirements on 4G, 5G, and beyond are getting translated to technology requirements, some with a bit of AI acceleration as well. Now, specifically from the banking and financial sector, we would say that one of the business requirements that potentially could be translated into a good technology requirement relates to non-public network, referred to as enterprise networks or private networks, where components that we are today using on digital public infrastructure, be it UPI or point of sale terminals or the micro ATMs running into few lakhs, could be enabled to improve trust and resilience and security in the financial systems. Obviously, this will require multiple telcos to work with organizations like NPCI or SBI or LIC and similar. But the impact that it can create and the security and trust that it can enhance would be a truly phenomenal with respect to challenges that we are facing today. For example, when AI assisted business requirement of saying that this purchase has happened in a particular geography, or this loan has been audited in a particular way, these things can be enabled. Obviously, the sector benefits, and then the network gets its own set of additional use cases and revenue streams to make it business viable. I will take a pause here and let others respond if they have inputs. So shall I build up on it a bit more, please? So a business requirement, for example, on low latency when we are talking of, and we are tracking a device for a payment of tolls on a highway or other logistic scenario of handling movement of goods and services in whatever stream we are looking at, the low latencies that are required or the reliability that is required, especially when we are looking at remote operation of vehicles in V2X scenarios, are business requirements that, when accelerated with AI in context of edge compute, placement of edge compute and all those things, would be important for the technology to meet and implement. Am I audible? Hemanji, back to you.
Yeah. So same question. Like thanks, sir. Now we move to Mr. Amit Srivastava from TEC. The same question, like whatever we asked to Mr. Abhishek Thakur, like what is the role play of AI in 6G in your opinion? Because you belong to Government of India thing, and you understand things little bit better from the deployment perspective, from the regulation perspective. So I want to understand from you your perspective.
Yeah, thank you so much. Am I audible?
Yes, sir.
Yes, sir.
Okay. So the question is about the role of AI and 6G, something like that. So from the TC perspective, let me just mention about a focus group which was there in the introduction part also. So we are part of study group 13 of ITU, and within study group 13 there is a focus group on AI NN, that is AI native networks. So for the last, I think more than 1 year we have been working on that. Lot of organizations are there, lot of countries are there, and I saw very good and excellent speakers today. So I wonder why they could not join actually. So I think a lot of work has already been done in the AI and still some part is left. So just 1 minute I will take to brief about that. So it has 4 different working groups, this particular focus group. One working group is working on the vocabulary, terms, definitions, etc. The other working group is working on the use cases, and the other working group on the architecture of AINN, and the last working group is on POC. So if you remember, we did a this sort of conference also, I think, with respect to our focus group, and Tata Elxsi was also part of that. So the POC part is almost complete in that focus group, and the report is submitted to study group 13, and that is on the public website also. If you just search FGAINN, you will find that technical report. The vocabulary terms definitions has also been finalized. What is actually AINN? These some of the definitions are there in that. Actually, that is also a technical report available on the FGAINN if you search the website. Use cases also is over. The main work remains actually is architecture. Of course, the reports which have been released can be amended, can be updated. There is no doubt about it. But the main is what will be the architecture of this AINN that is still going on. So I request the panelists and the keynote speakers, they are working on this field and they can join offline. I can let you know how you can join. So we have time till December 26th actually to submit the final report. So still, I think we can get very good inputs from the panelists and speakers about that, and can make a better actually report for submitting to study group 13. So that is one part what we are doing. Apart from that, in study group, a lot of work in collaboration with the industry, particularly TCS, and some and professors from few IITs. We are trying to make some kind of technical specifications and technical reports in the ITUT study group 13, that we are part of that. So, and especially the semantic communications, I can tell. So like with TCS, we are working on some kind of technical report on a semantic communications, and moreover the quality of service, quality of experience in the normal mobile networks. We know like what are the QoS, QoE parameters, but what will happen for AI related communications, what will be for semantic communications, what kind of QoS, QoE parameters will be there. So that deliberations are going on, and some contributions we have submitted. Apart from that, in government, the TTDF scheme is there. Probably in the previous session also, Ashok sir has mentioned about it. So more than 100 projects DOT have funded. And out of that, I think some more than 20 projects are there which are working on AI. So, we have taken some of the reports from that actually, and some of the work from that, on which we are trying to make some technical specifications and technical reports, and trying to take it to ITUT. So that's all from
Thank
my
you,
side with respect to government
thanks,
work at TC. Thank you so much, Hemalji.
Yeah, just one more thing I wanted to ask.
Yes, please.
Like already we have deployed 5G in India. Now to deploy 6G, what kind of roadmap we see in future, specifically for the migration of applications and the technology?
See, of course, this 5G is still not 100% utilized. If you see, actually, the 5G FR1 we are using, FR2 is still a lot of work is to be there. That's FWA. I think one of the speaker was mentioning about that. FWA is very important, particularly to have some kind of education in the rural area where the teachers cannot go. Similar is the case for the medical. Similar is the case for the other industries. So I think 6G will take it forward. That is one thing. And since it is AI enabled, so not AI enabled, this is AI native actually, that I can say. So obviously this, I don't know how the it will happen actually, how much investment will be there, but the lot of I think opportunities are there for startups and the different organizations to have innovation, because still we have some time for specifications to be released or the TPR to be finalized, like the evaluation part. So still we have some time left. So I think we have good opportunity to get some some Indian work to be like embedded in this particular technology to be released. Thank you, Hemanji.
Thank you very much. Thank you, sir. Now let's move to the academia side. Professor Nina Goes from BITS Pilani, KKBL Pilla Goa campus. Ma'am, you have been working on interdisciplinary research, and AI native 6G is really a major interdisciplinary area of research. Keeping your research focus in mind and your interaction with the academic community, we'd like to hear from you. How do you think that academia can contribute and benefit from AI for 6G?
Academia is the crucial factor when it comes to innovations. That is my firm belief. And like sir was mentioning about, collaborations with several IITs when they were making their documents, etc. I would very much like it to be in the future more democratic in the sense that inviting even other universities to participate along with these IITs. What typically happens is, universities which are not part of the government structure do not get invitations as easily. The other thing is, of course, we also look at applications which are like resource constrained, things which are necessary but not immediately required. And that kind of applications need to be done from the ground level up. So, for example, agricultural universities will come up with their own requirements. For example, medical colleges will come up with their own requirements. So there needs to be a bridge between these kind of applications and the kind of documents that are being made. Like, unfortunately, we look at it from top down where, that the network has to work well, AI has to do this. But then ultimately it is the user which has to, give the requirements correctly so that we can benefit, everybody can benefit. So what I would like in the future is for more participation from across university and of a kind where, application development is also kept in focus. Thank you so much.
One more point, ma'am, just wanted to add here. In the current research landscape, what are the research areas like for creating AI models for 6G we see today, specifically from academic community?
From academic perspective, we are looking at almost always for data sets and other things which we can use very easily to run things on. We do not have access to those things. So I am hoping that participation of companies, etc., in this process of initiating 6G and making it AI native would enable some data sets to be made available to researchers like us who don't have direct access to it. The other thing is, of course, having a bit more of interaction with the researchers instead of treating us like, like somebody who will do some research and publish somewhere. It is like, inviting us to be participating in their own work would be a nice future step. Of course, the other thing is, of course, we come up with ideas which are not usually thought of by the industry directly because we are doing research. So, for example, I look at AI models which should run on, let's say, a very resource constrained device. Is that of use to AI native things? Like, for example, I worked with tiny machine learning, and then I designed some digital twins for certain purposes. Now, would that be useful, or what is the kind of requirement that the industry has? Is this something just, as a research topic, or is it useful to the industry? I have no idea. But I would very much like to participate, or people like me would like to participate to make in the future all these things accessible and available to all concerned.
Thank you. Thank you very much, ma'am. We would like to move to the next panelist, Professor Sudhanshu Sekhar Singh from KIT University. Sir, if I remember correctly, you're quite involved and active in the 5G lab supported by Government of India. So my question would be like, how do you see that 5G testbed labs are contributing to this journey, to this 6G journey?
Thank you for being the part of this wonderful session. Actually, at the Government of India DOT initiative, we got the 100 5G use case lab in our institution. And in our organization, our working domain is split into two parts. One is for PG level research, intake and PhD students, those who work for 5G and 6G, mostly theoretical domain, mostly cognitive radio, mobility management, all other things. And the BTech level projects, prototypes, all those things we deal with 5G use case lab. And as you know, in Orissa, 4 institutions we are getting this facility, 5G use case lab. And we work as a cluster in coordination and cooperation with NIT Raulkela, IIT Bhubaneswar, SOA. We talk with each other and try to give the best features of the 5G use case lab to our students. And they are also actively participating in several hackathons, 5G hackathons, and generating some basic level development and design, or they are generating some prototypes on those platform. And it seems to be very helpful and effective for the students. And one thing I want to just discuss and give my views to the panelists. Does as from each generation to generation transition, like 3G to 4G or 5G to 4G to 5G, some basic features of the higher generation were given with the previous generation infrastructure. Similar way, is it the possibility that with 5G infrastructure, some basic features of the 6G can be implemented fast, or we are waiting for the full implementation or deployment of 6G infrastructure architecture? That is one thing. Another thing, the basic level concepts like your cognitive radio communication or mobility management, those will be very effective if you make it AI driven. Okay, all those things in relation with the 6G infrastructure. So that because the cognitive radio, though the concept has been developed much before, still it is not employed in 5G infrastructure fully. So all these things, can it be possible with fully 6G deployment or something like that? So all these my queries, it is put for the panelists. Can anybody answer my queries? Thank you for giving me a chance.
Thank you very much. Yeah, now we move to Mr. Vinos Babu. Vinos, I've been interacting with you for almost last 15 years. So the couple of questions that I would like to start with you. What does the AI native 6G truly mean beyond using AI and add-on feature networks?
Hemant, good evening, and thanks for inviting to this panel. Just checking my audio is clear, right?
Yeah. Okay,
thank you. I think to me, AI native 6G, it's actually means, it's a shift from what assumption we have today, where we are taking AI more for optimization tool, and it's actually supposed to go away into becoming a network's basic design. So what do I mean by that? Today, when we say 6G is used or 5G network is used, all that we are trying to do is tune the network after it is built, meaning it was done. Can I actually use this to actually improve the performance, right? In 6G, I think the expectation is the other way around. Can it be actually embedded into the planning? Can I actually make it part of the radio resource management? Can I actually involve it in sensing, orchestration, security, energy efficiency, and most importantly, can I actually improve user experience with that, right? A very simple example. There are network choke points, meaning there are places where we will have congestion. Today, we are fighting congestion, meaning that, there is a congestion. Can we actually try to find out, what better way to offload the traffic in there? But can we network actually predict saying that, there is a certain event going to happen in this particular place. I need to actually plan for more resource utilization today, or, this is a particular railway station, or this is a particular airport where you actually have more people having a footprint in here during a certain point in time. Can I actually optimize the resources at the RAN level, at the core level, so that, the user experience is seamless? Or can I actually manage it so that, the energy efficiency is improved, right? Very simple things like automatically turning on and off the system based on, utilization is actually going to improve the wallet size of the operator running the network, right? So these are simple things, we need to actually look for. But then the catch is actually the following, right? It's not just for network optimization. In 6G, the system will turn around and it will also become like it's a platform where AI workloads can be run at the edge, at the device, and most importantly, in a intelligent manner, right? So what do I mean by that? 6G should not just use AI to manage the network. It should also help AI run better across devices, at the edge, at the cloud, where it will actually make more sense and in a more energy efficient manner, right? So that is what AI native 6G to me is about.
Since you have been working with these standard bodies for the last several years, just wanted to understand from you, how can India contribute to global AI native 6G standards while addressing the local requirements and digital inclusion?
Okay, that's an interesting question. I think the honest answer from my end will be, if India can become like a validation ground, right, where a lot of these functionalities can be initially tested, those experiences can be quickly taken to standards bodies and then leveraged from here. That's where the value actually comes, right? So what do I actually mean by that? There is a commonality in terms of the use cases, what we experience deploying telecom technologies or even IT technologies like AI and other use cases, right? So things like, affordable coverage over wide areas, energy efficient networks, low cost devices, multilingual access, or, even resilient connectivity. You see these sort of use cases in several poorer countries, what we call as, bottom of the pyramid countries, and also in, parts of developed countries where, like in the underserved regions or places like that, right? So India's large deployment can actually help test whether this AI native 6G can support use cases like, say, for example, agriculture, telemedicine, education, or public services, where connectivity will be needed by small entrepreneurs in a practical and economical way, right? So by converting these learnings, say, for example, from test beds, trials, ecosystems, into evidence-based standards inputs, right? So that is the key, because in my view, the 6G standard is going to be like probably evolution of standard, which is going to stay for a long time. So if you can make use of this evidence-based approach in standardization and help shape the 6G technology to be more advanced, inclusive, and globally deployable, that's where India can add value. So, yeah, validation ground.
Yeah, thanks. We'd like to move now to the next round. In this round, we'll go in a different order. So we'll start with Professor Neena Goves. There is a question posed in the previous keynote session. What about the cross-domain data itself? So, ma'am, you have been talking about the data part. So just wanted to understand from you, what about the cross-domain data you are looking for? What kind of cross-domain data you are looking for, and how do you want to utilize the data? And what kind of data you really want from the industry community, so that we, through this panel itself, at least we can put that message to everybody.
So typically, if you have to develop any model, we would require certain kinds of data which are given to us. So firstly, of course, there are benchmarks where you test anything on. But then to develop, let's say, a customized model. So for example, sir was describing something about, a railway station having a lot of footfalls. I would definitely require that kind of data to be able to create models for that particular scenario. Now, of course, I can do it in a synthetic manner, but then that doesn't actually, give the correct kind of inputs to us to develop our models. Now, for medical cases, for example, it would be very good if we can actually get something which is relevant rather than come up with something synthetic. So data in the sense that all the use cases, all the places that they already are trying to cover in a certain way. Then, of course, if you're looking at the network itself, of course, in a certain area, there would be, places where there are more kind of routers and things like that and uses, whereas in other places, there is less number of available technology and something like that. So how do you balance these requirements is what the data is. Like if you get authentic, good data to work on, we feel that there will be much more progress in terms of both, developing models, validation with respect to, the actual uses. And then, of course, reality is very different from something which is simulated. That I do not, there's no way we can, simulate something without having a real data. So I'm hoping that, companies and others do come forward and set up benchmarks for us.
Yeah. Well, the data you are talking about is both the network data as well as application data. Like to move to from the application perspective, from the business vertical perspective, like to hear from Abhishek Thakur. Sir, the question also was posed in the previous session. AI in the network actually brings a cost and a business decision. Sir, what is your opinion about this, and how do you think that the data you are getting, you are generating actually from the application use case, can be utilized in an anonymous way with the research community?
Yeah, so getting the data is a challenge, especially when we're talking across application and network, though there are data sets available from a Western perspective, as well as some anonymized data sets that we may be having purely on application side. See, for example, if you're looking at a scenario like a user doing a video KYC and trying to ensure that all the security and trust and other things are in place, some of it can be simulated over test beds and data collected both on the network side and simulated application side. But as we go into more and more richer applications, it will need more expansive test beds. For example, we know that IIT Hyderabad has a vehicular test bed wherein they are able to simulate as well as have real vehicles moving around to collect data. So there has to be more proactive approach on the data side. Opening up the data side, as ma'am was saying, Nina ma'am was mentioning, this has to be a focus effort for the researchers so that the contributions from academia is strong and relevant to what the sector needs. When we are looking at other scenarios, for example, today in BFS, again, I'm coming back to BFS because that is the domain I belong to. We are using telecom for aspects like SIM binding or device binding or OTP and similar, as well as for the data access for mobile banking, online banking, or even enterprise level workflow for field-based banking or agent-based banking through Bank Mitra, Bank Sakhi, whatever channels we would talk of. Now, related to this, pilots have started with respect to usage of silent verification through camera APIs and similar, wherein a device, rather than being authenticated directly through an application running there, the network can start vouching and reporting about it. So more such scenarios will have to be created to cross leverage telco business scenarios. Obviously, the 5G private network and beyond extending into 6G will allow parts of even the core network to be shared with the application vertical. That will enable more control and more services to be possible there. And just building upon the previous keynotes, where in the second keynote, I think digital twins was being discussed. We were also discussing multi-domain ontology. As we enhance on it, I think some of the data problems or data sets we are looking at, it's chicken and the egg there. So the ontology will feed into data sets, and the data sets will help the ontology become richer. So we will have to have those scenarios also looked at. And then again, the speakers did talk about holographic natural language processing. These are scenarios that for inclusive banking, doorstep banking, we also need as a vertical, or maybe a transportation or a manufacturing sector as a vertical also needs those. Manufacturing may not need natural language processing, but a lot of digital twin and similar scenarios will be needed. So how do we create these synergies is a challenge. I don't want to say that it's trivial because still we are not talking enough across. We are still, even in 5G, what exists, we are not able to leverage enough. Probably some of the private networks being set up would start creating data that can be tokenized, masked, or privacy enhanced to be shared.
Thank you. Thank you very much. Now, just to connect to this particular point with what Professor Singh was telling earlier, sir, the use case lab you have today, like what kind of use cases like you are handling or you are creating there itself? Like as Mr. Abhishek was talking about a lot of financial things and a lot of other use cases. Professor Nina also spoke. What kind of use cases you have been handling and you have been creating, and whether you are using actual realistic real devices for the use cases or using simulator or emulators for that?
May I take this question, please?
Yes, yes, for you only. Yeah, thank you.
Okay. Normally, our students developing prototypes on healthcare applications, agriculture applications, very small scale, drone-based applications, and even if some simulations we used to just validate the things, but prototypes that. And most of them are participating in different hackathons also with those prototypes what they have developed through this use case lab.
Okay. No, the taking it forward to Mr. Amit from TEC. Sir, there are several startups we see today, like in the startup ecosystem. And what role should the startups play in India's AI native 6G ecosystem, in your opinion?
Yeah. So thank you for this question. So startups actually will be playing a major role, in my opinion, in shaping India's AI native 6G ecosystem by driving innovation, as I was mentioning earlier also, in core telecom technologies. Because, you know, the ideas are there with the academia. What works are going on in 3GPP or in ITO, that also we know. But unless if the startup is involved, sub industry is involved, I think it is not going to be materialized. And that we have seen also in the TTDF funding in DOT and in MIT also. They are insisting that some industries, some startups should join with the academia so that it can be taken forward. It should not be just a research kind of idea. So obviously, in my opinion, they are going to play a major role, because the 6G, AI native 6G is still like evolving. It's not yet complete. It is going to come in 2030, maybe 1 year before the specifications will be there, released 21 kind of thing. So tremendous opportunities are there in RAN, in core, in like OSS, network orchestration, edge intelligence, digital twin, as we were talking about. Semantic communications is one area which will be coming in a big way, in my opinion. And some like the energy efficiency kind of thing, and autonomous network operations also. Lot of work actually will be there, because some spectrum is already given for this autonomous, this V2V communication, you may be knowing. So in my opinion, a startup is required to work closely with academia, telecom operators, the equipment vendors, uh, and the standardization bodies also, like TSDSI or TEC or maybe 3GPP, etc. So that they can get some proof of concept developed, some kind of validation also can happen. And this will also make sure that they will have some kind of IPR generated, or they will be part of the IPR generation work along with the academia. So
Thanks.
I think there is a lot of scope for the startups to join this work.
Thank you. Thank you very much. My last question would be to Binos. Binos, you are from telecom industry as well as from semiconductor industry. So the question, what support or impact we would be experiencing from the semiconductor industry specifically for this perspective?
I think the semiconductor industry is going to play a very important role. So if you look into what this AI native 60 will bring in is, we'll need to have efficient compute everywhere, right? As I mentioned, it has to be on the device, it has to be on the RAN, it has to be on the edge, and it has to be also there on the core network. So, for example, if a phone or maybe a car, vehicle, whatever it is, industrial camera can run AI locally, it will reduce latency, it will improve the privacy, and it will actually avoid sending every piece of raw material back to the cloud, right? So this will mean that you need we will have to have more power efficient AI accelerators, advanced modem, RF capability, sensing, secure hardware foundation, and scalable platforms for distributed AI. So ultimately, the semiconductor innovation will influence whether these ideas become practical, affordable, and energy efficient at the scale, right? So just 4 points. A, computer will become part of connectivity. Your modem, RF, sensing, all those things will have to be integrated. On-device AI will matter. Energy constraint is going to be defining it. And the standards and chip must align, right? So standardization capabilities should be implementable in silicon at scale. So early feedback from the semiconductor players is going to be important for practical 6G design. So they are going to be central to it.
Thanks. Thanks to all my panel members. So, we'll now open to the all questions and Q&A sessions. If anyone having any questions, we can discuss now. And let me also read a couple of questions from the chat also. There's a question: is AI considering user traffic under priority traffic or entertainment traffic or traffic blockage like pornography content? Anyone can answer from the panel itself. Like AI is considering user traffic under priority, like whether if I understand correctly, how can I understand the traffic itself and block the traffic if something is required?
So I can means the blocking I cannot comment on, but as far as the contributions in ITU is concerned, that I can just means mention like the contributions are discussing about how to offload the traffic from mobile networks to D2M. D2M, like the contents are there, or some kind of software download is there, or some like it's not a two-way communication. So how the traffic can be offloaded from the mobile network and can D2M or other networks can be used. So this kind of work is going on, and apart from that, some like network congestion, because ultimately whatever technology you bring, the network, the bandwidth, etc. Like will be like there will be constraints actually. So how the semantic communication can be deployed to utilize the bandwidth even like much better way. So these kind of discussions, these kind of deliberations are going on. So that's all from my side. Other members may like to add in this. Thank you.
Another question was there. I think the 6G architecture is being defined. What kind of multi-agentic solutions do you have in mind? I don't know either for us or for previous speaker, but okay, we can answer. Is there any other question we have for this panel itself?
One question just may I ask you from my query.
Sure.
So now everybody, last two speakers also, keynote speakers also talk about AI for networks and networks for AI. AI for networks, it's obvious because for several applications, several smooth conduction of the application point of view, from the user point of view. So AI for network is understandable, but network for AI, that is somewhat little confusing in the sense how somebody can just modify or make the architectural change for a specific network. That is little difficult to understand. So anybody can just clarify my queries.
I actually had put that in my slide, if you permit. Hemantji, can you answer that question?
Okay, sir. I shall
So,
go through that.
maybe you
That
can
is,
explain that part, sir.
No, I'll answer that very simply. Today, if you do a download right now of speed test, you get a 10:1 ratio. So you are getting 10 times the download speed, and uplink is 1 time. When you start using AI in the network, you are pushing tokens, images. If you do chat GPT right now, you're pushing data up, for which you require almost a 4:1, 4 speed of download, 1 of uplink. Now the network today are designed for the 10:1. If you start using AI, the network has to change in time. And all the time, everybody is not going to use chat GPT or AI. So in urban areas, this will happen. Rural areas, this will not happen. So you will need to design the network which allows you AI loops. That's one. The second is, if you go back and look at all the data centers which are coming up, a lot of data centers which are going to have a lot of AI GPUs getting pushed, how will that work? An application, for example, if you speak in Odia, I speak in Hindi. If you have an application which does a conversion, we should be able to convert while speaking. It can also happen on 5G, it can also run on 4G. But if it uses a bit of artificial intelligence to be able to smooth our conversation, that requires the pipe to be AI consistent. And those are where the network has to be able to take care of AI loads. All the tokens that you're pushing are AI loads. They're pure data. But the amount of data that is going is increasing multifold.
sir, my submission is that that was simple to change a architectural change of the network if it is needed.
No, the architect. So it is like saying that you have a large pipe, small pipe, your pipe should change. It's like coverage, sir.
Okay.
Your busy hours are between, let's say, 8 to 12 in the morning, and the busy hours of the network run from 4 o'clock till about 8 o'clock in the evening. That's busy hours. Today, you do a lot of SON work to be able to do coverage, to be able to put capacities here and there. With AI in place, you will need to do it faster and better. The two problems that you still have. How do you trust the AI? The speaker earlier said we need data to be able to train the LLM, but the data is not there. If you go back and do a Google search anywhere in the world right now, you will not find a lot of telecom data even by GSMA, on which you can train your AI. So that's problem one. Problem two, the data inside the telco, something has to be trained for it to be used. But you still need to be able to modify the architecture, what's happening. So that is why the telecom will need to change for AI traffic to get carried. And it will not happen everywhere. Urban areas, schools, colleges, not the villages at the moment. Villages will still be a lot of download looking at videos or course content. So that's why you have to think that through, sir, for the next 5 years and then step back. Right, sir?
Thank you.
I hope I have answered your question.
Thank you. Thank you.
Thank you, sir. Thank you.
Okay. Now, I think we're at the end of this particular session. Let me summarize the thing. Like, we had 5 panelists, and we had very wonderful discussions. A lot of interactive questions, answers were there. Mr. Abhishek brought a lot of business aspects, specifically from the BFS perspective, and Mr. Amit brought the India-specific context, as well as the focus groups and several working groups related to ITU study group 13 also. And then Professor Nina brought the data-specific requirement and the kind of use cases, kind of like research the academic community is doing, and the usability of those research, those IP they are getting generated there itself by the industry community. And Professor Singh brought the use case lab, connected the use case lab aspects and how exactly the use cases are getting translated to real life applications. And then we had Binos, who brought a lot on the standardization aspects, brought on the semiconductor industry aspects, as well as specifically from the India specific requirement, those things. It's very quite an interesting session. I'd like to thank all the panelists. So unfortunately, Professor Jyotsna Bapat couldn't join in the session today. So, but like we should also thank to her because she has contributed a lot during the discussions, the pre-panel discussions, all the things. So thank you everybody. Now let me hand over to my colleague, Mr. Jesu, to take it forward. Thank you very much.
Thank you, sir. Hello. Thank you, Hemant sir, and thanks for the wonderful panel discussion. I would like to bring in the concluding remarks. Probably a few minutes I'll take to summarize what we've done today. This is for the session that happened now with the AI Native 6G session. As we come to the close of this highly insightful session on the AI Native 6G, let me take a few moments to reflect the key themes that emerged today and the larger message they collectively convey. When we opened the session, we spoke about how the discussion on AI and 6G has evolved from the visionary conversations of TTDD 2025. Today, through the perspective shared by our keynote speakers and panelists, it has become clear that the AI Native 6G is no longer a futurist concept. It is rapidly becoming an architectural, operational, and standardization reality. Our first keynote by Professor Sundaram Manka challenges to rethink intelligence at the most fundamental layer of communication, the radio layer itself. The concept of RF semantics moves us beyond the traditional spectrum sensing towards contextual understanding of wireless environments. It showed us that future networks must not simply observe signals, they must understand their meaning, intent, and surrounding environment. This represents a powerful shift from communication-aware systems to a cognition-aware systems. Our second keynote by Mr. Jnana Prakash Sebastian expanded the discussion to a broader network architecture. We heard how AI native 6G can be viewed through three complementary dimensions: AI embedded into networks, AI for networks, and network for AI. We explored the role of agentic AI, digital twins, knowledge graph, and sovereign AI infrastructure as a foundational building blocks for autonomous, trustworthy, and scalable telecom systems. The vision presented was not merely about network automation. It was about transforming the telco infrastructure into a distributed intelligence platform for industries and for the society. And our third keynote speaker by Mr. Aditya Chaudhary sir brought an equally important perspective: the need to earn AI native 6G through standards, interoperability, and deployment realities. He reminded us that the future cannot be built in isolation from the networks we already operate. AI native 6G will succeed only when the intelligence can function across multi-vendor, multi-domain federated environments. Most importantly, he highlighted that the standard window is open now, and the choices we make today will shape the global 6G ecosystem for years to come. Together, these keynotes formed a complete narrative. First, AI must understand the world. Second, AI must operate the network. Third, AI must scale through standards and collaboration. The panel discussion is another interesting perspective which further reinforced several important priorities. Mr. Hemant sir actually already summarized it, but I'll give a few points that were discussed in it. There was a broad recognition that future 6G system will require trusted and governed cross-domain data sharing, federated AI pipelines we talked about, explain and accountable AI, digital twin-based validations, knowledge-driven reasoning, and open and interoperable standards, human oversight and responsible governance, sustainable and energy-aware AI deployments. Most importantly, there was a consensus that AI native 6G is not solely a telecom challenge. It's a cross-disciplinary transformation involving communication, computing, intelligence, data governance, cybersecurity, cloud, edge, and industry verticals working together. Another recurring theme that throughout today's discussion was the unique opportunity before India. India has already demonstrated its ability to influence global telecommunication through initiatives such as connectivity, rural coverage, innovation, and digital public infrastructure. AI native 6G presents another such opportunity. By combining our strengths in software, AI, telecommunication standardization, and large-scale digital adoption, India can contribute meaningfully to the defining global framework, architectures, and standard for future networks. As we conclude, perhaps the most important takeaway is that AI native 6G is not about faster networks or smarter algorithms. It's about building a trusted intelligent infrastructure that can support future economies, industries, governments, and societies. The journey from the connected networks to cognitive networks is underway. The journey from automation to autonomy is already begun, and the journey from the communication infrastructure to intelligence infrastructure is now becoming a reality. On behalf of the session organizers, I would like to express my sincere gratitude to our distinguished keynote speakers, panelists, the moderators, the TSDC leadership, session coordinators, and to all participants who contributed for this interesting discussion. Thank you all for your insights, your questions, and your commitment to shaping the future of telecommunication. Let us continue this dialogue beyond the session as well and work together to ensure that AI native 6G is not only about technology advanced, but also bringing in an open, trusted, inclusive, and sustainable, and make it globally impactful. Thank you all and have a wonderful evening. Thank you so much. Any concluding remarks from Chandrakanta ma'am or Madan sir, please?
Yes, sir. So I'm sharing my
you.
screen. Yes, so thank you, sir, for your inspiring concluding remarks. And before we conclude, we kindly request all participants to share their valuable feedbacks on today's session. Your feedback is extremely important to us and will help us further enhance future editions of the TTD conference. You may submit your feedback by clicking on the feedback link shared in the chat window or simply scanning the QR code displayed on your screen. We sincerely appreciate you taking a few moments to share your thoughts. Thank you once again for your participation and engagement throughout the session. So we warmly invite you to join us tomorrow for another exciting day of TTD 2026, featuring the following technical sessions. Session 3, Security, Privacy, Trust in 6G, from 2 p.m. to 4:15 p.m. ST. And Session 4, Apps-Based Connectivity, Technical Feasibility, Trials, and Market Dynamics, 4:30 to 6:45 p.m. ST. Have a wonderful conference experience, and
Thank you. Thank
we
you.
look forward to your continued participation.
Thank you.
Thank you so much. Thank you.
Yeah.